Hello, welcome back. This is our Leaving Certificate Mathematics class. This is the third edition of our probability class and also the third edition of our flipped classroom. So again, just a quick recap on some of our probability resources, namely the 52 deck of cards. We'll be using this today for theoretical probability. Also as well, what's used quite commonly is the dice and your numbers from 1 to 6 there on your spinner. So today we will focus on theoretical probability. So what is this? Well, it's the probability of an event, or sometimes PE, which is equal to the number of desirable outcomes over the total number of all possible outcomes. So we'll go through two examples here. The first, we look at a probability of getting a red card and the probability of getting a king. Okay, so I'll do this by showing you 52 cards now on the table. So we're asked to find the probability of a red card. Okay, so going back to our formula, it's the number of desirable outcomes over the total number of all possible outcomes. So the total, the number of the desirable outcomes we want, well, look here, and it's a quick recap. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards in each deck. Sorry, in each suite. So that's the 13 diamonds, 13 hearts, 13 clubs, 13 spades, and when you add those together, you get 52. Now we're looking for the probability of a red card. Well, if there's 13 diamonds, and then there's also 13 reds, then we would have 26 in total. And if you add all of them together, 13, 13, 13, and 13, you would have 52. So from there we've identified that there are 26 red cards. Okay, so you have 26 red cards, so the total number of desirable outcomes is 26 over the total number of all possible outcomes, and we also identified that it's 52 cards in a deck. So 26 over 52, and you always simplify the fraction here, so divide both sides by 26 and get 1 over 2. So next then we're asked to find the probability of a king. Okay, again, what is the number of desirable outcomes? Well, we want the king. How many kings are there? Well, if I look here, there's 1, there is 2, three, and 4. So there we have 4 kings. Okay, so see the 4 kings there, and let's put them back. We have 4 kings out of a total of 52 cards. Okay, so again, 4 kings, that's the number of desirable outcomes that we want, and the total then is 52. So again, just to do the math side of it, in your written probability format, we're asked to get the probability of a king. Well, we've already identified that there are 4 kings, so the number of desirable outcomes, well, there's 4 kings over the total, again, always 52. I simplify that, well, if it's divide both sides by 4, I'll get 1 over 13. So that's the probability of getting a king. So next then we're asked to find the probability of a king. Okay, again, what is the number of desirable outcomes? Well, we want the king. How many kings are there? Well, if I look here, there's 1, there is 2, three, and 4. So there we have 4 kings. Okay, so see the 4 kings there, and let's put them back. We have 4 kings out of a total of 52 cards. Okay, so again, 4 kings, that's the number of desirable outcomes that we want, and the total then is 52. Okay, so the next question we have then is the probability of a face card. So a face card is basically a card that has a face, such as a king, queen, or a jack. So there's 3 of diamonds, 3 face cards, another 3 in the hearts, another 3 in the clubs, and 3 in the spades. So that's 12 in total. Or you could just get, the amount of face cards from one suite. So that's 1, 2, 3. There's 4 suites. 3 by 4 is 12. So what I've done is I've taken away all the cards. We know that there are 52 cards in the deck. So I've just put the diamonds, king and queen, the hearts, clubs and spades. So when it says or, it means you can get a king or queen, and that means in probability you add them together. Okay, you can add them because king or queen, king, queen of hearts, clubs and spades, etc. So the number of desirable outcomes that I want is any one of these 8. Okay, king or queen, and that's out of a total of 52. Okay. So the last thing we want to look at here is, this is a blackjack table, okay, and here we have the numbers from 0 to 36. If it lands on an even number from 2 to 36, we double our money. If it lands on an odd number, we lose. Likewise, if it lands on red, we can pick red, we can double our money, but if we pick red and lands on black, then we also lose our money. So I want you now to work out the probability of getting a red, black, an even or odd number. Okay, and I want you then to think about, is it fair? Okay, so is, for example, the probability, is it 0.5 for an even, 0.5 for an odd? Okay, so just try and work that out now.